Today, I'm going to cover the second part of the control flow or control flow structures that will include iterative statement and loops in Python. As you know, I mentioned last time, conditional statements in Python are used to execute certain blocks of code based on specific conditions. If the conditions are met, so a block of code or a set of instructions can be executed under a specific condition. This helps to control the flow of a program by make it behave differently depending on the situation. So the conditional statements determine how when a certain block of code or statements in the program can be executed on which condition, if they should be repeatedly executed. So we need to use the loop instruction that will be controlling the flow of the execution of a program. The control statements in Python are categorized in three main structures. We have the sequential structure, which is the first one, the default mode of executing Python instructions line by line. We have also the second category of control flow instruction, which we have covered in the last session, is the conditional statements, where we have instructions that help us to implement decision-making or selection instructions. So for conditional statements, we have two main instructions. We have the if and the match. The if itself can be also implemented depending on the situation in three main statements. You have the if without any else alternative. In the other case, you may include the else alternative. In the case the condition of the if statement is not fulfilled, you can take another alternative. So in the third one, we have a kind of nested if, an if inside another if, which can be implemented as if, else, or if else, depending on the situation. So today we are going to cover the third control flow structure in Python that will be used to implement loop in Python or iterations. So in Python, to implement a repetitive block of statement of instructions under specific conditions, we can use two approaches. We have the first one is the for instruction, which is used to build loops in case you already know the number of iterations that need to be implemented. In the other case, we have also a while loop, which is also used to implement iterative block of instructions under a specific condition. In the case of while, although if you don't know the number of iteration, you can use it to implement your logic. Start now with each of the Python provided loop instruction, okay, that are used to implement the execution of a set of statements or a block of code multiple times. Okay, so loops in Python are basically used to repeat efficiently activities. In Python, we have three types of loops. The first type of loop can be implemented using the for keywords, as I've mentioned, to implement repetition of statements multiple times, mostly used for counting through items. The second type of loops in Python is the while loop. The while loop also is used to repeat a statement or a group of statements under a specific condition. But the small difference between for and while, for you should know exactly how many times you are going to iterate. But with while, even if you don't know, it's okay to control that by defining only the condition to exit the loop. So the third type of Python loop instructions is the nested loop. With the nested loop is the combination of one or more loops inside the for loop or while loop. So we'll see these three types of loops in Python to implement iterative logic in the program. First of all, to clarify, about the loop statements in Python. So you have to define the statements that need to be repeated. And as long as the execution of the program goes beyond the scope of the loop, all the objects that were created under the scope of the loop will be automatically destroyed. That's why Python is said to be a automated garbage collecting programming language. That means all the resources that has been created when the scope of the loop is exceeded, so all the objects using the memory will be destroyed. That means we'll clean up the memory and all the resources. So for control statements in the loops, Python provides three mechanisms to control the flow of the loops in Python. The first keyword is the break, because you can implement a loop which iterates continuously without ending. In order to prevent such kind of situation, you can determine or set some condition that can break the execution of the loop. So break is the first control flow for iteration in Python. So which is used to terminate the loop statement and transfer the execution to the next statements coming after the loop. That means the intermediate loop statement will be executed. And the second control flow is continue. In the case you are in the loop and you want to skip a remaining part of instructions inside the loop under a specific condition, you can use continue, which automatically will remain in the loop, but will go to reset the condition prior to reiterate again. So the third one is pass. Pass also is one of the control flow that can change the behavior of a loop statements. It is used to provide specific control flow in the loop, especially when a statement is required systematically, but you don't want it to be executed. So you may face some situation. Like I've explained last time in the if statements, as these control statements are implemented on multiple lines. Okay, let's assume that you are implementing if condition or a loop with for or while, but you still didn't, let's say, figure out what will be the logic inside those compound statements. You can still use pass keyword to all the space, and then you can come back to feed that space with the appropriate code. So this is the role pass can play in some situation. So how can we now write loops using Python as a programming language? This is the question we are going to answer throughout this session today. I will provide several ways to write loops depending on the situation using the three approaches I have introduced with 4 statements, or while statement, or the nested loop that will be the combination of one or several loop instructions together. Depending on the situation or the problem you want to solve, it will require some logic to be implemented. You have to make a good choice of the right statement that need to be implemented. First of all, let's start with the loop statements with the 4 instruction in Python, which is the easiest way to implement the loop in Python. Like other programming languages, Python also provide for in statement to implement loops, which is the equivalent of for each in other programming languages such as C or C++. In Python, using for statements, it will be implementing a logic to execute a sequence of statements multiple times, and it will abbreviate the content, the codes that manage the loop variables, because the variables inside the loop will be used to store or save intermediary results until the loop is completed. So for loop is used in many situations. The use case of a for statement can be to go through a sequence of elements. Okay, it is used for sequential traversal operations, such as traversing or exploring a list of objects, or a sequence of characters like a string or an array. So those are a few use cases of for loop instructions. The statement of a for loop instruction, it's defined as follows. You have the header of the instruction that starts with the 4 keywords, and then you have the iterator variable that should be initialized, and then in following the domain or the domain in which the for should be iterating. It can be a sequence, it can be a range of values. You have to define that by yourself, and then it will finish by this column, which shows that this is a multiple line instructions. So all the statements that will follow this column should be indented inside for. So you may have one instruction or several statements that can be provided inside a loop. This is the pseudocode structure to represent the for loop implementation. We can also visualize that using the flowcharts, because we have learned that the flowchart also is very useful to visualize more clearly to visualize more clearly the logic inside the code. Like here, representing a for loop in the flowcharts, we have to provide first the variables that will be used to control the loop. So we have to initialize them, and then after initializing them, we can start the loop by checking the condition that will be used to control the iteration, okay, until the condition is verified. So if the condition is true, we will access inside the loop and execute the instructions that are inside the loop until the condition for exiting the loop will be met. Like the condition of exiting the loop, for example, we have to loop within the range until n. When the value n is met, the next iteration, when we test the value of the current iterator variable is beyond the scope, then we can exit and go to the next instruction following the loop. So this is the syntax to implement the for loop in Python. So let's take an example for the first use case of loop to count, okay, in a range of numbers. So let's write a small program in Python that will be printing numbers from 0 to 9. So for us to implement that, we can use just one instruction. So the instruction will be for, this is the iteration instruction in Python, and then we have an iterator variable, which is I. This I will be used to control the number of iteration, the number of time we'll be repeating the instruction inside the for. And then in main, we need this iterator variable will be changing in this domain of values. So that means within the range of 10, 10 is the end, the maximum value of I within this case. So every time we'll be running this print instruction, this print instruction need to be indented, showing that it is a sub statement inside prints. So we, inside a for loop, we'll be just printing the value of I. When we start with the first time, I will be equal to 0, okay? And then we'll check here whether 0 is greater than, let's say, is greater than or equal to 0. So this can be, for example, a statement that can be determined. For example, in this case, it doesn't match with the context. So we should change the way of testing. So we are going to test that the value of the iterator is less than or equal to 10. Okay, this condition is met. So we will print the first value, that will be 0. Then after executing this instruction, I will be added, will be increased. So we'll have I here will be increased with 1. We go to the next step. We loop again, we go there. So we'll check for the second time whether the condition is met. This time, for the second iteration, I will be equal to 1. And then we check again here whether the value of I, it is in the range. 1 is less than 10, then we can print the second value, that will be 1. After printing this value, inside the for instruction, there is this incrementation instruction, which is implicitly implemented inside the for. So we'll go to 2 until we reach the condition that will be 10. And then since Python start counting from 0 to n, so the statement should be n minus 1. N minus 1 will be the last step for the iterator of the for statement. That's why we start from 0 to 9. Launch the notebook studio. I hope everyone is able now to test the Python code locally using whether Anaconda or VS Code. Here's the scripts of all the code in the class material. Okay, now it's fine. So here on the right side, I have the instruction which I've provided with the outputs. But when I run it here, you will see it will show the result as follow. So these 4 statements will just print the value of the variable I that will be changing within the range of 0 to n minus 1. N is 10, the maximum value that can be taking the variable while iterating. So I will iterate 10 times from 0 to 9. So this is the first use case of for loop instruction. In the second example, I will show how to use the for instruction to iterate over a sequence of objects, whether it's a sequence of characters as a string or a sequence of a list of objects or a tuple or any sequence of elements. Let's say we have a list of characters provided as a string, a keyword like banana, and then we can use the for loop to travel throughout all the sequence of this string. For us to do that, we can just use one line. It's enough to implement that in Python using the for keyword. And then we have the iterator, which is the variable here, in this case, name x. We have to specify the domain in which the iterator will be changing for each iteration. So x will be changing within the domain of this sequence of characters, which is a string. And then for each iteration, we have to print the value of the x in that iteration. So for the first time, x will be mapped with the first character, which will be b. That means for the first iteration, it will be b, which will be printed. And then x plus 1, it will go at the second position. It will be a. And then the third position, it will be n until it's reached the end of the domain, which is the word which has been provided. So it will print banana, each character inside the string banana. So to test that, I have the scripts here. So for this case, when I run my code, you will see it provides exactly what I've just explained. Here is the results. You have for x in banana as a string value, it will print each character one by one. So it's travel across this sequence of characters. This is the second use case of the for instruction. The other one, it can be to iterate through a list of objects. Let's say we have a list of fruits, okay, names, like a variable which is used to store a list containing names of fruits. We have apple, banana, cherry, and orange. Those are the values stored inside the fruit variable. So for us to travel inside this sequence of objects, we have to use for instruction to read any element of the inside the variable fruit. So same, we have to use the keywords for, and then the iterator variable that will be using the value inside this domain. The domain here is fruits. Fruit has only 4 objects. That means we'll iterate 4 times. Okay, we iterate 4 times, and then for each iteration we have to print the value stored inside x. That means for the first iteration here 0, we will x for the first iteration will be equal to 0. We will print the first element at the position 0. Then the second iteration x will be incremented at 1. We'll print the second objects which is at the second position. X here is representing the objects at a specific position. So this third iteration x will be equal to 3. That means we will print the value of the object which is located at the third position until we reach the end. That will be 4 equal to the length of the list. In my scripts, I have this code which is fruits initialized as a list of objects, banana, apple, cherry, and orange, and then 4x, as I've explained. When I run the code, you will see it prints the contents of the fruits one by one for each iteration. The third case, in this case, let's see how we can use the pass control statements inside a loop. So for loop, when it's empty, let's say you just start coding, you write the first header line of 4, and then you go directly to the next line, implementing another instruction. As I've explained last time, I have this case. Okay, I'm writing a 4 instruction, like, okay, 4x in, for example, let's say fruits, as I've mentioned earlier. So in this case, I don't have to initialize fruit again because fruit is already in memory in the previous cell. Directly, I'm going here, and then I'm writing something like prints end of for loop. Okay, end of for loop. Okay, so like this, I didn't figure out exactly what I have to implement inside the 4 instruction. When I run this, you will see the interpreter will show an error saying that the block following 4 statements, it is not provided. I didn't implement properly the syntax of the for loop. Okay, but in such kind of situation, let's say you are going to implement later the logic inside the 4 statements. For you to avoid such kind of situation, you can use pass, okay, keyword that will be used, for example, to hold the space. And then when you run the instruction this time, you will see it will work properly. So pass, it's a control flow statement which is avoided by the interpreter. So that means inside the block of 4, as I have demonstrated, I didn't put any instruction, okay, that need to be executed for the 4 to iterate several times, because the value which is used to iterate, like x in this case, it doesn't change because there is not any statement inside a loop that make the loop to repeat and again. So to avoid such kind of situation, you can use pass in order to avoid to get error from the Python interpreter. So as it is shown here, you have just to put this keyword pass inside the 4 instruction. It will be holding space for you to fill the related code later. In the other case, here you have 4 that need to be implemented in order to read the values inside a list of integer numbers, goes from 0 to 2. So you can also use pass again here to hold space for you to build the logic later. So this is very important, especially when you implement big size of codes. So if you don't manage that properly, you can face some difficulties. Okay, let's see now another case where we can combine loop instructions and conditional instructions we have seen last time. In this case, we can combine for loop with if-else statement, which is combine in order to provide a specific control inside a loop. So this is also a kind of nesting control structure that's combined a loop instruction and conditional statements. So for this case, we can control, okay, in the case where the statements of controlling the loop, it is not fulfilled, okay? We have another alternative inside the loop. For example, here we have inside a loop, we say I, okay, should change within the range starting from 1 as the starting point, and then the ending value will be 6. This is the range in which I should take its values while we are iterating this block of instructions. Inside the for instruction, we have a conditional statement. So when this condition to enter the for loop is verified, then we can go to this line and check if this if statement is verified. Then we can print the message saying that, okay, this number is even. If this condition is not satisfied, we can print the message that this number is an odd number. So this is a program which is used to check whether a value is an integer value is an even number or an odd number. Prepare the script. So for me to show you how it works, you can see here for each iteration, for the first iteration, I have I, which is equal to 1. The remainder of the division of 1 by 2 is not equal to 0. That means it is not a odd number. Okay, it is not an even number, it's an odd number. We'll go to the else branch. And then the second iteration, in this case, we will see when one of those conditions, okay, it's verified, we go to the next iteration. So that means we will increase I by 1. And then 2 is in the range of 1 and 6. Okay, the condition is verified. And then we reach this step, checking whether 2, the division of 2 by 2 using the modulus, the remainder is 0. The condition is true. Then we'll go to this then branch. It will be even number until we reach 5. Okay, 5. Okay, will be the last step, because here the loop needs to iterate. Okay, until n minus 1. Here n is 6, and then n minus 1 will be the last value of I, unless you want to control that situation by yourself. In another case, I will show you here. If you don't want the Python to control the initial value of I, you can control that by yourself. Let's say, for example, in this case, I initialize myself the value of I to start by 1. Okay, so in this case, when I run this code, it will start automatically with the value of I 1. Okay, it will not let the Python interpreter to initialize by default with the value of 0. Look at this case. When I run the second case, you will see also the situation here. I'm controlling the value which start from 1. Okay, and then although I start from 1, the value when I divide with by 2, that case will be skipped. So that was just a small detail I wanted to mention for you to control the iterator value when you use for. So I've shown how to use for with task control statements, and then with if else conditional statements. Now I will show how to use for with break. Okay, the break statements is used to stop, okay, the execution of the loop and then exit the loop when this key word is met. The statement syntax is like this. You have for as keyword the iterative variable in that determine the relationship between the iterator and the domain in which it's take values. Then I have this column that say I have now to define the block of code that need to be iterated. Okay, and then there is an indentation, which is very important now. Be aware of the indentation, because if you make a wrong indentation using the loops, you may get another result from what you are expecting from the program to provide. So here I have the block. This is the block of statements that need to be repeated. So in this block, I would like to control which one need to be repeated and in which condition. Okay. Then here I have a if, which is a control statements. And then with the if, I need to provide a condition under which I have to exit. If I meet this situation and the condition is verified, so next instruction will be break. At this time, I will definitely exit the loop and then go to the next instruction following the loop without running these statements. Okay, I hope it's clear. Then this was the pseudocode representation of the loop statement with break and if control statement to determine when we have to break and exit the loop. So in terms of chat flow, we have all the time to start with the initialization of the state variables that will be used to control the loop. And then we need to set the condition, okay, for us to enter the loop. If the condition is not satisfied, we will never enter in the loop. So if the condition is satisfied, depending on the value initialized for the iterator, if it's satisfied, we can execute this statement until, okay, this statement is true. If this statement is false, we will still running inside the loop. And then when these statements will be verified, that means this break, we will exit. So this is the same, the representation of this pseudocode statements in the flowcharts. Let's take an example we have used earlier. So we have our list of fruits, okay, which is a list objects, which is stored inside the fruits variable. And then in this case, let's loop inside the value of fruits, and we'll exit when the value of x will be banana. Whenever we meet banana inside the list, we exit the list without going until the end of the value inside the list. Okay, here we have the definition of the for loop. We have always to provide the keywords to define the for loop, and then the iterator in this domain. That means the value inside the fruits, which is a list of objects, names of fruits, and then we have to print the value of x. Okay, then will be this conditional statement. If the value, the current value is banana, then break. That means exit the loop. If not, we will go back again here until we meet banana. If we don't meet banana inside the list, that means we'll go until the end of the list, and the for instruction will be terminated normally without any interruption. The example I have mentioned with break. Okay, in this case, if these statements, okay, is verified, I will break and exit, go to the next instruction, showing that loop ended because banana was found. Okay, in that case. Okay, and then if there is any instruction coming after break, it will not be executed. You will see the output of these codes will only provide apple and banana, because banana is the second position, and the loop will be exited without going until the end of the list. Okay, that means cherry and orange will not be shown or printed. So in this case, let's change something. You will see here we have break inside if instruction. That's control when we are going to exit. Now let's print the result after the if instruction. Here you see print is located before the condition. You will see in this case the behavior will be different. So when you are dealing with the loops, be aware of the indentation and the position of the instruction. If you put a specific instruction at the wrong position, you will get a wrong result. Like in this case, I have first to test and then print. That means if okay, banana is located at the first position, I will not print the remaining part of the list because I'm printing after verifying. But in the previous version, although banana it is at the first position, in this case, banana at least will be printed and then we exit. Then, okay, in this case, let's see, x will be equal to 0 for the first iteration here. We'll have to check whether apple here is equal to banana. The condition is not verified. We will skip break here and then print the apple. Second iteration, we go there. Second iteration, x will be equal to 1, the second position in the list. What is the value located at the second position is banana. Then we'll come here. Banana is equal to banana. Then we'll run break without printing even banana. That means in this case, we'll print only apple. We will check that with the code here. Just by changing the position of print, we put print after the test and then see the results. It's changed automatically the logic. You see here, I print only apple, but in the previous one, we printed at least 2 values. I hope it's clear. The position of the statement inside the loop and the indentation are very, very important because they may affect the behavior of your loop. I will add one more example. In this case, I will use a list of colors. Okay, I have a list of colors, and then I put a condition to exit the loop when the color is red. Same thing like this, like we have seen in the previous example. In this program, I have first to initialize the list of objects through which I will be iterating. I have the variable colors, okay, which is used to store a list of colors: blue, green, red, orange, yellow. They are values, okay. They are represented as objects in a list. And then I save that in memory, which is colors. Then I use the for loop to read the content of the list. For me to read the content of the list, I need a variable which will be used as an iterator. I call it color. Color will get the value inside colors. Okay, and then I have to check here the block for this block inside the loop. For it to be repeated, this condition here should be false. Okay, if this condition is true, automatically I will exit. So I will repeat until this condition will be true. For the first time, I have x here that will be equal to blue. I will check whether blue is equal to red. Not. I will skip break, and then I iterate again. I go to the next iteration. X will be equal the value of color, not x. Color will be equal to green. Color will be equal to green. I will check again when I get that iteration value, and then as a current value inside color, I will have green, which is not equal to red. I will skip break, go to the next iteration until I reach red. It will be red, which will be equal to red, and this condition will be verified. Then I will go to break. Break is a statement which is depending on if statement. That's why it is indented. Okay. If I put break at the same level with if, it will provide error. Okay. So to show you the code, how it works, I have prepared here. You have this code. When I run it, you will see it prints only 2 values, blue and green, because the third position is red. Okay. Let's say, as I mentioned, instead of indenting break, I have break at the same level of indentation with if. If I run this one, you will see it will provide error because the statement of if is not properly implemented. Okay, let's change now. This time the position of print. Let's put print before if. Okay, instead of putting print here, I put it just before print, before if. When I run this, you will see at this time red also is printed. So if I don't want to print red, I need to design my logic properly. You can see the codes, it's not, it's correct basically, but it doesn't fulfill a specification. If they say we have to exit when the value is red without printing red, these codes will be wrong because we are printing red. We have to use the previous approach by printing after verification. Let's say another person has solved this problem as follows. Instead of using print before if or after if, someone mistaken and then take this instruction and it puts it here. This print instruction do not belong to the for loop. Okay, it doesn't belong to the for loop. If I run this one, Python will give me an error because color here will be initialized only after running this instruction. Look at here. You will see in this case, I will take only the first value before we access the loop, because only this line will be executed. Okay, and then the color will be printing the value inside that variable, and then you will see here this will not iterate, will not print all the contents of the lists. Be aware of that; they are very important. I've covered the pass, control, if else. Now let's see how we can use continue inside a loop. The syntax is same like break, but continue here will not break and exit the loop. It will just stop the current iteration and then continue to the next one. Okay, this is the statement here. It will just continue, go to the next statement without exiting the loop. For the flowchart representation is a little bit different from the previous one with break, but the initial part is same. We have to initialize the iteration variables, and then those variables will be used to make the conditional the loop conditional statements. And then for this case, we will exit only if this condition is false, or when the continue if statement is false. So if the continue condition is false, we'll just skip the next instruction and then go to the next iteration. Okay, with the same example, let's take the same list, but this time let's print the element of the list, but let's skip banana. Okay, in this case, instead of using break to exit, but we can print all the content of the list, but let's skip banana. How to do that? We have just to implement this if statement. When this condition is met, we continue. That means we go to the next iteration. So I hope that is clear. Then let me show you that case. In this case, with continue statement, when the value inside the list for the current iteration is banana, we don't have to print it. Okay, that's why we put prints after the if statement. If this print statement is located before the if, we will violate that constraint, and we will not satisfy the condition. You will see here all the object inside the list are shown here: apple, cherry, orange without banana. Continue, just help to skip the current iteration and then go to the next one. Okay, I will now cover the range. Okay, after covering the range, and then I will give you some 10 minutes break, and then we come back for the next part. The for loop can also be combined with a range function to determine the domain. I've shown two examples using range, but now let me explain how to use the range function to determine the value of the domain in which the for iterator variable will be changing. So the loop can be controlled because we provide the number of time the for loop can be repeating the block of statements under this condition. So I have shown with the example that is used to count until we reach a specific number. This is simple, okay? But let's say the other case now, we use the function like we can determine the starting point and the ending points. That will be shown in this second example. For you to determine the starting and the ending points using the range function, provide two values. The first parameter will be the value that will be used to start, okay, the iteration of the loop. Then the second value will be the end, okay, the maximum value for the exit of the for loop. And then you can define the block of statement that need to be repeated under which condition. You can also add the if condition to control that, break or continue control flow is statement. So let's say an example. Here we have a counting that starts from 2 until 6. The end value will be always -1, okay? Unless you define it differently. If you provide the parameter like this, Python will always take the end -1, okay? Be aware of that. So this example will start counting from 2 until 6. It will iterate from 2 until n-1. That means 6 minus 1. That means it will count from the value starting from 2 until 5. 5 is n minus 1. That's why 6 is not included. If you want to count from 2 to 6 plus 1, you should put 7 here. Then it will be 2, 3, 4, 5, 6. So 6 also will be included. Be aware of this setting. The way you set the end will determine how the result will be provided by the loop. In the other case, you can also determine the step. You have the starting point, which is the first parameter. The second parameter is the end. Then you can also control, because by default, Python increments the variable by 1. If you don't want to increment by 1, you can provide the value that will be used to increment this iterator variable. Like here, I can start from counting from a starting point until the end by setting 3 as a step. Okay, like in the previous example, I say, okay, I should start counting from 2 to 30. But this time, the incrementation will be at the step of 3. That means I will have 2, 5, 8, until I reach the end. That will be, in this case, n-1. That will be 29. Okay, I will just show this case and then go to the next example, because those two cases I've already discussed. Then here is the example. You will see here, it starts counting from 2, and then it skips the 2 digits between 2 counting numbers. So we have 3, 4 are skipped, and then we have 6, 7 they are skipped. You can see the step here is 3, 3, 3, 3, and then the bigger number will be less than the end, okay, value of the loop. This is the way you can control the for loop. So now let's see another statement of loop, okay, for, because so far we have just seen how to control the statement inside the for loop. But in some cases, you may specify the condition, okay? If, for example, the condition to enter the for loop is not satisfied, within the previous examples or statements, we go directly to the next instruction following the for. But in this case, if the condition to enter inside the for loop is not satisfied, we are not going directly to the next instruction, but we go to the alternative else. Okay, this is another type of using for loop statements. So this part is similar to what we have seen, but here we have else. Else is used to manage the cases where any condition has been satisfied for us to run this set of instruction, unless we can run the else parts. So to give you a sense of this case, let's print all the numbers from 0 to 5, okay, and then print the message when the loop is ended. Okay, for that we have the first part is similar to what we have seen, and then here to acknowledge that the loop has been successfully terminated, we take the else and then we print this message. So this is the role of this second part. With the example, if I show you here, you will see how it works. You see it counts from 0 to 5 because I want to count from 0 to 5. That's why I put the number I want to get plus 1. You can see here the range goes to 6. And then this is the end. It's for me to check the successful execution of all the iteration inside the loop. Okay, and then here I think is the other case where we can combine if else and break inside this loop statement. Is same like what we have seen. In this case, we added just this part of else. But in this case, if this condition is satisfied, we will never run even this else block. We'll directly exit to the loop. That's the small difference. Look at here, what will be the results? When I think I run this code, I will never print this is the end of the loop, because here I have the break statement. Okay, this break statement is used to control and change the behavior of my loop. So I will never go to this part if this condition is satisfied. Okay, this can also be used in a real world use case. For example, we do use banking services. Okay, when you go to the ATM, they ask you to provide your PIN code. Most of the time, they provide a limited number of possibility. Okay, most of the time, let's say they provide 3 times, and then they can lock the accounts if you exceed the number of attempts. So for loop can be used for that case, combined with the if and break statements to control the number of iteration and exits in that case. So let's see. Here is the program, basically a snapshot of the program running behind the banking application when they ask you to provide your PIN code and then they check. It's the similar logic. So for me to address this problem, I have to understand the context. Okay, they say I have to iterate 3 times. Okay, in this case, they say I should validate the PIN. I'm trying to understand the problem statements. This question includes something which is not explicitly mentioned in the problem statement. It assumes that the user has to provide the inputs. Okay, so for me to address this problem, I have to think of the mechanism or the instruction or statement I will use to collect the PIN from the user. So in my problem solving approach, I understand, and then for the 3 possibilities, I have to use a loop. Which loop I will use? I will use for loop, and then when the PIN match, what I have to do? I have to acknowledge that okay, the PIN has matched. So this is the way I'm solving the problem in my mind. Then after figuring out the all pseudocode or solution, I can write the pseudocode if I have time, or I can just keep that in my mind and go directly to solve the problem. So here I have the 4 statements which needs to provide a variable that will be used for iteration and will take the value within the range of 3. Okay, I have 3. It will start from 0 to and 3. 3 minus 1, that means 2. And then in this case, since I have to provide the user to provide the PIN until they reach the maximum, I have to provide the input. So this statement has to be inside the loop. This is very important, because if I put this statement outside of the loop, I will only get 1 time. Okay, the PIN, and then it will not fulfill the requirements of my problem statement. So here you can see I have put this statement at the right place, and then to interact with the user, I have to provide a message like, okay, enter the PIN. Then I will check using the if statement. PIN should be equal to the value of the PIN, which is already defined earlier in the system. Let's assume in this case 1, 2, 3, 4. If the provided PIN in that iteration, which should be less than 3 attempts, it's correct, I can acknowledge that, okay, it's correct, and then provide access by showing the message access granted. And then I will exit the loop, definitely. If not, in that case, I will show the message invalid. If I'm still in the range, I will give another attempt. If I'm outside of the range, I will go to this line. That means this condition will not be correct. I will go to else, show the message over 3 attempts. Look at here, the indentation is very important. I have this block that belongs to the for loop, okay, when the condition is satisfied. This block will be executed if the loop condition is not satisfied. And then inside the loop, I have another if statement. I have first level and second level of indentation. It's very important. If you mistaken to put the instruction at the right position, it will affect the logic. That's very important. Okay, let me see how it works through this example. You see, I've prepared that. When I run, you see it asked me to provide a pin. Here's the message. Okay, enter your pin inputs. Okay, let's say I provide a wrong 1, 2, 3, 5. Okay, they say it's a invalid pin. I provide another 5, 3, 2, 1. Invalid pin. I provide another 1, 8, 9, 4. It worked properly because I provided 3 false pins, and then it's run properly until the condition of the 4 is false. It shows overtime. This time, let me put the rights at the second attempt. Codes 1, 5, 3, 4. First one is invalid, and the second one I put 1, 2, 3, 4. Correct. Access granted. Okay. You see the program, it works properly, and then it satisfies the requirements. The second type of loops, while loops in Python. A while loop in Python is used also to write iterations in Python. So it's basically repeatedly executing a set of statements or a block of statements as long as the specified Boolean expression is true. So until the conditional expression is false, we can exit the while loop. So it starts also with the keywords while, and then the conditional expression that should get a Boolean result, true or false, and then it's end with column symbol showing that is the end of the header part of the loop instruction, which is a multiple physical line instruction, but it's implementing the logic on several physical lines. And then the lines that will follow the column should be indented, okay, to implement the statements or the group of statements that need to be executed as long as the while condition is true. So on the right side, you have the pseudocode representation on the left and the flowchart representation of the while loop condition on the right, where we also need to have the initialization of the loop statement variables that need to be declared and initialized, and then we'll follow the loop Boolean expression that need to provide the condition under which we can enter the loop and exit the loop. As long as the condition is true, we will be looping until it will be false to exit and then go to the next instructions, okay, or terminate the program. So there are some similarities with for loop, but the big difference between loop and for loop and while loop is, in case of for loop, we have the control of the number of iteration. If you already know in advance the number of iteration, it's better to use for loop. If you don't know exactly how many times you are going to iterate, you can use while loop and set the condition to exit the loop. Okay, let's take an example we used previously for counting from 0 to 5. So with while loop, always you have to initialize the loop iterator variable before the while statements. But in the for loop, in the header line, you initialize and then you determine the end, okay, of the loop in terms of domain in which the iterator variable has to take values. But in while, it's different. You have to initialize first the iterator variable before the line which is used to declare the header of the while instruction. Then here you can write while, then you have the iterator variable, you set the condition, okay, which and while the counter value is less than 5, then you have those column, the column symbol, and then you have the block that need to be repeated, okay, until the condition is false. So inside here, we have also to control the incrementation. That means the value of the iterator variable in case of for, it's automatically managed by the Python interpreter. But in the case of loop, we manage that by ourselves. So which is also important to increment or decrement the value for you to iterate. So another important point to keep in mind while you are using while instruction is where to put the incrementation instruction. Should you put it before the statements that need to be repeated or after? So depending on the location, you will put this incrementation statements. It will affect the behavior of the loop. Then we will be repeating this instruction. Okay, you will see. Then when this statement here, the condition will be false, we will go to the next instruction to print the message saying end of y. Okay, this is the way it works. We will see now some particular cases, as I mentioned earlier, to be aware of the position of the incrementation. Okay, here you see the while function here, it's first initialize the value of the counter, and then you have here the condition which is defined here. If the condition is not satisfied, we cannot even enter inside the loop, and then we increment the value of counts plus 1. So we do the unary operation. We take the previous value of count, which that was 0, and then we add 1. We'll be incrementing. Then we will print the message iteration number. Then we print the value of the variable counts until this condition will not be verified. The result you can see here as we visualize the execution of Python program. I mentioned last time Python program visualizer. I guess you can remember that. Python program visualizer, you can go to Google and then you can see which one is good. Let's take any. This one, the first one. You have this Python visualizer. I will show you what is going basically under the hood when we run this loop. So I paste this code here. Look at what is going behind the scene. Okay, I have my code. I will run it to show you what is going on step by step. You will see when the compiler or the Python interpreter will be pointing on the first line. Look at what is going to happen. We'll create an object in memory which will be called count. Is the name of the variable which is used to store a value in memory. That will be 0. The global frame is the memory. Okay, the memory, and then it will go to the next instruction. Okay, where we declare the while statement, the header statement. When it's run that line, it execute that line, nothing basically happen. It's take only the condition for the while to be executed. Then what will happen? We will run now the block of instruction inside the while. This time you will see the value has been incremented to 1. It was 0, it's 1 now. Okay, in memory. This the execution of this line. Then we have this the next line. Okay, red color. You will see it will output these results. Iteration number 1. You see, this is the first iteration. Then I go next time. You will see I go again to check this line, and then it points on this second line because the condition here is satisfied. Then when this line will be executed, look at now the global memory. What has happened? The counts will be increased by 1. I have 2. Then I will print the message iteration number 2 and then 2. It goes again on the loop. It checks whether the current value inside the count, which is 2, is less than 5. The condition is true. When it's run that line, it will go to the next statements inside the loop. Look at here. The frame memory here of count, it's 2. When this instruction is executed, it will be 3. It's increment 1. And then it will output this message, number 3. You see until 4, and then look at now 5. Look at now the last round. It goes there, it's check, and then directly it go to the next line because 5 is not less than 5 or 6 because we are at the 5 plus 1. It will go directly to this line because the condition was not satisfied. Then if I run now this step, you will see end of the loop. This is just a tool to give you a sense of what is going on behind the scene. So now look at this particular case. I mentioned that you have always to initialize the variable, okay, that will be used to control the loop before the while loop statement. And then look at here, I've initialized that, and then the incrementation was before the print statement. Look at now here. If I put this incrementation statement after the print outside of the loop, you will see it will affect the logic I would like to implement through this while statement, and it will affect also the result and the behavior of the loop. Look at here, I put the increment outside of the loop. Look at here. You will see this time when I run this code, you will see that it will keep running continuously with the same value, which will be 0, because I don't increment. So the value will be always 0. It will be running infinitely the loop, but with 0, 0, 0, that will be repeated. So be aware of that when you put the statements that need to be used for controlling the behavior of the loop. That's why the while statement is a little bit complicated than for statement. For statement, it's easy to control that, but with while statement, if you put at the wrong position the increasing statement, it will affect that. Be aware of that, and do not mistaken the initialization of the iteration variable that's used to control the loop, and then the increase. That means the next increase for running the next iteration. Inside the while loop also we can use if statements like here we have in this example we have a flag variable which is initialized to 0, and then in the while we use that flag which is 0. 0 basically is one of the representation of the Boolean value. That's why this one in this case this condition will never change. That means we will print this message like given flag is really true, and then goodbye. So we will not iterate because of the nature of the way we have implemented our logic. If I run this, you see it just show goodbye, and then it doesn't print this statement, because this flag basically, for us to access the loop, the condition should be true. If I change it to 1, let's see what will happen. If I change it to 1, you will see, I will have another behavior of this logic. So in the way you are controlling that, in this case, it will be running forever because this condition will, this flag will always be true. See this mark here, star, it shows that it's still running. So it's still running forever. So because this condition is always true. So that's the problem with while loop. Be aware of the conditional statement. Otherwise, you will have some infinite loop that will run forever. You can also use some control statement like break. Same as we use it in for. When you use it in while, it will also stop the loop and exit when this statement is found. But mostly it's better to combine the break with a conditional statement. If we need to determine under which condition we can exit the loop with the break instruction. This program say that we can print or count from 0 to 3, 0 to 5, and then exits when we will reach 3. Okay, so you see here we have the variable is initialized at 0, and then while statements, the condition is to iterate until I is less than 5. If I is equal to 3, that time we can exit without running the remaining part. Incrementation to loop again. So we'll directly go to the next line, which is prints when the breaker is found. Okay, let's see the results. When I run it, you will see it shows 0, 1, 2, and 3. Okay, it's break when 3 is reached. Okay, I can also show you that using the visualizer, so you can also see what is going behind the scene with this case. I go again here, I paste this. So here in the visualizer, you will see at the first step, the interpreter is pointing on the first line. Okay, where I initialize, I create an object which is called I, the variable, and store value of 0 inside. Then I check the while, okay, loop condition. If the condition is satisfied, I can enter inside and run the block inside. Otherwise, I will go to the last line number 7. Okay, so this condition is satisfied. You will see I go to the next line, run the print I will print the value of I. It prints 0. And then I will go to the next statement, is if statement. If I is equal to 3, the condition is satisfied. I will not run this break. I will skip it and go to the next instruction. Here is the incrementation. I will increment the value of I by 1. Next, you will see now it's 1. I go again, check the condition. 1 is less than 5. Okay, I go inside, I run this line again. I print 1 here, and then I check 1 is not equal to 3. I go to this, I is updated to 2 until I reach 3. Look at now, 3 is 3. Okay, I print 3, and then 3 is equal to 3. Look at what is going to happen. When I click next, you see break. Now I can run break because the condition has been satisfied. Then okay, I will exit the loop from break line 5 to line 7. Okay, then my loop has been successfully terminated. So this is the illustration of the use of break with while statements. You can also use continue instead of break in while. The fact is, with continue, we'll just skip that round and go to the next round. So the position of continue is the same position where we put a break. Let's see that with the example directly. In the next example here, we have continue. What does continue do? You will see the result here. With continue, we just skip the current value. We skip the current value, which is 3. So we don't print 3 because it's the current value. And then we go to the next round. The behavior with continue, when I go in the visualizer, you will see this time when the condition of if is met, we will not exit, go to the line 7, but we will loop again until we reach the loop exit condition. Look at here, the first step, I create object I with value 0. The condition to entry the loop is correct. Then I increment I by 1. I check the condition is true. I print I until 3. At 3, you see it's print 2. It goes to the next line. Look at now, I will be 3. Okay. And then when I come here, I is 3. Okay. I is 3. And then if 3 is equal to 3, this time I will go inside the if. Now I can run the line number 5. And then I will skip to print to go to print. I will directly reset the pointer and point to the while. I check whether the condition is satisfied. You will see until the exit condition is met, I go to line number 8. So this is the behavior of continue inside a while loop. I mentioned earlier, the while loop is so dangerous, okay, if you don't manipulate the variable very well. You may face some situation where you have infinite loop that run forever. So it can be leading to many cases where the system can crash down or can waste resources. So be aware of that, because if the condition as you have set inside the loop statement does not have the probability to be false, that will run forever. So be aware of that. Make good conditional statements for you to escape such kind of problem. But in some cases, we may need infinite loop, like server and other applications that run forever. We use while loop because it's never end unless you end that manually. So this is something important you have to keep in your mind. How to implement infinite loop using while? You have just to put the condition true, like I've shown in the previous case. While flag was set to 1, that was an infinite loop. This one also will print this message forever. Okay, like this. When I show you how it behaves, you will see it will waste resource. So this one, when I run this condition, okay, it will be always satisfied. You see, it's still running in the background. You can see the star. This star showing that this cell is still running, and then it's wasting resource. It's running forever. So unless I interrupt that manually, for me to stop that, I have to click here on the stop button. Otherwise, it will be running forever. And then when I run on the stop button, you will see it will even show me an error message, because it will be using a lot of resources in the background. So be aware of that. Do not make such kind of mistake unless you need to implement such kind of use cases. Otherwise, it will be difficult for you to control the loop. So be sure to use the right statement for the loop. Okay. And then in the other example here is with a variable. I have this variable which is set to 1, and then this condition is set like this. This will always be true if this variable does not change. Okay. So for this kind of cases, you may also face trouble if you do not put condition properly. Like this value, this will always run and ask the user to enter number. Okay. For the run to reach, for the program to reach the prints goodbye, neither to be verified. Okay, let's see what will be the behavior of this loop. So when I run this loop here, you will see the first line is okay, second line is verified, and then it's asked me to provide a number. You will see it will keep asking me to provide numbers. So I don't have any way to exit. It's an infinite loop. I can provide whatever number. So this can be difficult to manage. Okay, it will be wasting resource. So I will show you how you can deal with such kind of cases inside a loop. So with those infinite loop, you have just to interrupt them manually. And then when you interrupt them manually, you can see even the system is showing that there is something issue, because it's an infinite loop. Okay, with that said, I will go to the next. So be aware of that when you implement your loop, okay, condition. And then loop also can be combined with other control statement like if else to control how you can shift from one block to another. Like in this case, we have to control the case when this conditional statement is not satisfied, or when we exit the loop. Before we go to the next statement, we need to implement the alternative with else. Okay, like in this case, we initialize a variable at 1, then I, as while I is less than 6, we'll be printing the value of I and then increment it to go to the next iteration. So when this condition is not verified, we will go to else and then print I is no longer less than 6. Okay, this is quite reasonable. You will see here, when I run this code, you see it's count from 1 to 5, and then when I will be equal to 6, it will exit and show this message. In the other cases, okay, you may also provide some statement inside else, okay, like this. This case, for example, in case of L, of else. So this will be run only when we will go beyond this condition. So counts will go from 0 to n minus 1, that means 5 to 4. And then when we do no longer verify this statement, it will go out of the scope and then print this while else statement. Here, you see here, it will count 1, 0, 1, 2, 3, 4, 5. In this case, you see here, 5 also is included. Okay, 5 also is included in the counting because 5 is less than equal to 5. Okay, that's why it also includes such kind of situation. So when you put the statements, make sure to understand what will be the output of that Boolean condition. If you do not want to include 5 in the counting, you need to set that properly here. Okay, like just go up to 5, up to 4. So 5 will not be included. If they ask you to do not include 5, another approach is to use, for example, continue statement here inside. So I can say, I can correct this one, for example, to count without 5 included. So I can just take this code and then here inside, okay, I just put continue here, okay. With continue, I will not print the last value. When I run this one, you will see I will, okay, when you put continue, you have, in this case, you see I put continue. In the case of continue, you will see I didn't put any condition. I put just continue, but it goes directly to the next statement. That will be, it will go to else. So I cannot just put continue like this. I need to set a condition, okay? So here I have to put if statements, if counts, because I want to escape the case of 5. I don't want to print 5. So it should continue, should be inside an if. So if I run this time, this, you will see it's count from 0 to 4 without counting 5. I hope this example is clear enough. In other cases, you may be facing such kind of situation to combine nested if inside a while loop. When you have a problem statement that asks you to build a program that is asking the user to guess 5 times a number, okay, which is initialized before. So in this case, first we have the loop iterator variable, which is I. We initialize to 1, and then we set the secret number, which is 7. Then we give the possibility to the user to provide the guess number. We have to check whether we are in the range. So the range is to check 5 times. When we are behind the range, we need to print a message saying that 5 attempts and then game over. So what should be now implemented inside the loop? What are we going to implement to check whether the guess has matched or not? So that will be inside this while, okay? And then all the statements need to be indented. First of all, I have to ask the user to provide the inputs, which should be stored in a variable. I use guess variable that will be used to store a number that will be provided by the user as an input, and then I cast that value as an integer, okay? Then I will check whether the number which is provided match the secrets. If it match, I will write correct. If not, I can give a hint to the user by saying whether the number is too low or too high. For me to implement such kind of logic, I use L if. So I will check again whether that guess number is less than secret. If it's less than secret, I print too low. Else, I will print too high. Then, for me to iterate, do not forget this one. I need to increment the value of the variable that will be iterating to go to the next step. I hope the explanation is clear. So here is the script I've explained. When I run this, look, it's asked me to provide a number. Okay, let's say, okay, I provide 15. It say too high. I provide 10, too high. I provide 4, it's too low. I provide I have 5 attempts, right? I provide let me try to fail all the cases. 9, it's too high, okay? And then I provide another number, which is, for example, 8, which is also wrong. You will see I have reached all the number of attempts. Okay, I have 5 attempts without matching the guess number. This case, let's try. Okay, I have 8, and then I put 7. 7 is the right match, but you can see it's keep asking me to guess the number. I would like me to, if I want to exit, okay, this program after matching, what do I have to do? I have to use break after the statements coming the match. Okay, so I don't want to continue asking. Okay, in that case, what I have to do, let me just because this one will keep running forever. Okay, I want to stop that when I reach the number. Okay, I can stop that, and then I go here when it's matched. If I put break like this, okay, when I put break, automatically I will exit. Okay, let me run this one again because it's still running. I will running again. I have first to stop that. Escape. Because you can see here, I don't have any way to escape because it's running forever. I have to force that, okay, by stopping the kernel, which is inconvenient. So for you to avoid that kind of situation, use some mechanism to control that. So here you can see it doesn't allow me to do that. So I don't want to restart my kernel. I just make another cell. Okay. So do not use infinite loop. They are inconvenient. So if I just repeat the same code and then add the break here, when I run this, the previous one still running and ask for inputs. Let me provide all the inputs and then I provide 5 attempts and then I end. Okay, you see it's inconvenient when you have such kind of loop. But now I would like to control when the number is found, I need to exit automatically. In that case, I add break just after correct. So look at now, this time with break, when I provide second time, third time, I match. When I match, it's directly exiting the loop. So those are kind of the cases you may face. And then the other one is an example for reading notes, okay, for an assignment, for example. You have the score, and then we have to classify them as you are providing them. So we have a while loop. This is almost the same program running on the server, okay, which is used to calculate grades. So it's accepting notes. So here, this condition will always be true. You need now to specify in which case you have to exit the loop. For example, here we can exit the loop when the user will provide a character like Q to quick and exit the loop. So this is the way you can control such kind of loop. As long as this condition is true, this block will be running unless the user provides Q where we test the input provided by the user. So we have here inputs. The user provides the inputs and then we store that in the user inputs. We have to check whether the input provided by the user is a Q character. So we take all the content, we put them in the loop cases, and then we compare whether it's equal to Q. That's the only condition we can exit. Otherwise, we check here. We need now to classify whether the value provided by the user. We check whether it's a valid digits. Okay, we use that function is digits, and then we can now here cast the value provided by the user as an integer value that will be assigned to score, and then we can match the value of score. If it's greater than or equal to 9, it will be A plus. If it's between 90 and 80, it will be A. If it's between 80 and 70, it will be B. If it's between 70 and 60, it will be C. Otherwise, it will be fail. And when the user will add this key Q, we will click and print the message invalid inputs. Okay, here is the program I've explained. Then when I run this, you will see it's asked me to provide a grades. Okay, like I say, okay, I provide 90. Okay, 90, okay, is in the range of 90 and above. It's A plus. And then I provide 85. It's in the range of 90 and 80. And then I provide 45 is fail. So for me to exit, I have to provide Q to quick, and then I exit the loop. So this is convenient. Is the upgraded version of the grade management program we have seen with the control statement. So to wrap up about all those two cases, I have discussed so far the for loop statements and then the while loop. For and while loop can be combined with the control statements break, continue, and pass. Break exits the loop. Continue, skip the current iteration and go to the next. And then pass is doing nothing. It's just a placeholder. The for loop is used when you already know the number of iteration, okay? But the while loop is repeating the instruction while the condition is true. This is what I can say about those iteration. Now let's see the nested loop. The nested loop is just a combination of those two loops I mentioned, while and for. So inside loop, you can have another loop. So this is what we call nested loop. So for example, inside a for loop, you can have another for loop or a while loop and vice versa. So when they are combined like that, we call them nested loop. And then a nested for loop can be implemented as shown in the screen. This is the syntax. You have the outside loop, okay, which is defined with the related iterator variable and the condition or the domain in which that variable has to take the values. Then the inner loop should be inside the for, indented like this. It's also a full loop statement with its own iterator variable with the same approach. So we have the outside loop, and then the inner loop statement, and then outer loop statement. This is the syntax of a for nested loop. Then we have seen our example of fruits. Now let's match. Let's take an example to build a Python program which uses nested loop to print each adjective for every fruit in the list. We have a list of adjectives, red, big, and then tasty. We have the list of fruits. We have two lists. Each for loop will be used to explore each list. The first for loop with X will be used to explore the first list. And the second loop with Y will be used to explore the fruit. So same as we have seen, we have now to combine the statement that will be printing, combining the object in the first list with the second list, X and Y. When I run this, you will see is matching the first object, this one, with all the second object, because the inner loop, we go to the next step only when all the inner loop will be completed. So for one X, we have to match all Y. And then the next X will match also all the Y. So here you have red 3 times because we have 3 objects in fruits. And then big 3 times, we have 3 objects in fruits. Same for tasty. So this is an illustration of a nested for loop. In the other case, we can take an example of a script that generates number pattern using nested loop. So you have for loop, the outer for loop, as I as an iterator variable that goes in the range of 1 until 5. That means n, 5 minus 1. And then the second loop depends on the value of I all the time. And then we'll be printing the value and then space just to make a pattern, okay? It will be like this. the outputs. So when I run this example, you will see it works. So the code provide this result. For the first iteration, when I equal 1, okay, j here will be 0 and I 1. So I iterate one time and print this one. When I is equal to 2, j will be equal to 1, okay, will be equal to 0 and I to 2. So I will iterate for the first time, print the value of I, that will be 2, and then I iterate again for j from 0 to 1, and then it will be 2. The next step will be here, I will be equal to 3. When I is equal to 3, j will be equal to 2. Then I will take I here through 3, and then I will iterate 3 times, mentioning 3, 3, 3, 3. And then you see it's help to make a pattern of numbers. Same, you can also use it for figures. Okay. Another use case of nested for, we can also use to make another pattern, okay, of numbers. This time, the inner loop for also has a range of value, which is almost similar to the outer range. And then we will print the value of the current iteration for A and J, and then we go. This means we go. This is like the equivalent to the tab key on the keyboard. That means you go 5-step blink space. Then we print nothing and then print nothing. Okay, let's say this one will be creating this pattern. This is the tabulation. This key is making this space. It's like you are hitting on the tab button. So when I run this example, you will see here it works and show the pattern. So it will print 1, 1 for the first iteration, second iteration 1, 2, second, third iteration 1, 3, and then for the inner loop, and then for the outside loop, when I is 2, it will take 2, 1, 2, 2, 2, 3. Then it take the next I, it will print 3, 1, 3, 2, 3, 3. So this is also another illustration. In the nested loop, we can still also use a control statement like if else, break, and continue, depending on the logic we want to build. Like in this example, we combine if else and break, okay, to find prime numbers which are between 10 and 20. So we have the first loop, which is a variable num that take its value from 10 to 20. With the normal iteration, it will be increasing by 1, 1, 1. If we were using while, we have to do +1, +1, +1 by ourselves. And the inside loop take I as a variable, and then it take the starting value 2, and the end value will be n, and num. It will be depending on the value of num. Then it will check whether the value inside num modulus I is 0. If it's correct, if this statement is verified, it will determine the first factor, and then go here, calculate that j by taking num divided by I. Then it will print here the value that will be n num will be printed here by, this is just a formatting. I will explain that when I will show how to print the string. So this is a plus order saying that at this space I will put this value, and in this also there are plus orders for numbers. Okay, that means it will take numbers that may be also decimal numbers. So the first place will be filled by this value coming from num, and then this one will take the value coming from I. This place will take the value coming from j, and then I will break if this condition is met. Otherwise, I will take the next step until I reach the while exits condition. So when I run this, you will see how it works. It will print 10 equals 2 multiplied by 5, and then 11 is a prime number, and then 12 until I reach n minus 1. 20 minus 1 is 19. This is another example for nested loop with control statements such as if else and break. Okay. We can also have while loop nested, a while loop inside another while loop. So same thing for the first while loop, we need to provide the expression, okay, to enter and exit the loop. Remember that for while loop, you have always to provide the initialization of the variables, both inner loop and outer loop. You have to provide the initial value before you define the loops. And then the inner loop will be related to the block of the main loop. And then the inner loop also will have a statement or a group of statements that need to be run. So same, you have outside loop, inner loop, expression, inner loop statements, and outer loop statements. Here you have an example. The same example we have seen earlier. Let's now try to build the while related version. You see here, we start first with initializing the counter, and then we have the while statements, which is initialized, and then the J statement. Okay, here you have to be aware, especially for the inner loop variable. If you put this J here, all the time the J will be reset to 0 when I goes to the next value. But if you don't want that, you can put it outside. But this means all the time for one cycle of the outside loop, you need a full cycle of the inside loop to run. This is basically the main logic we build from the previous one. And then the instruction we add here is just the incrementation of the loop for the inner loop and the outside loop. If one of these statement miss, whether the inside or the outside loop will not be, it will give the same result as we have seen for the 4 statements. But the 4 statement is easier to implement, but the loop is so complex, especially if you miss. Let's say, for example, I forgot to provide this one. Okay, if I provide this one, and then when I run, look, it will just be repeating this inner loop, because it will be only 1, 1, 1, 1, 1 as an infinite loop, because I does not change. So be aware of that when you use a while loop. It's very important. You can see now it's wasting my resource, and then it will run forever. It will require me to refresh again the page. So while loop are so dangerous. So be aware when you use while loop with the appropriate condition. It's easier to face such kind of situation while using while loop, so they are so sensitive. Be aware of that. So this may make a system to crash, so and cause many issues. So this is also the same problem we have solved earlier, but this time with while outputs version. Same, we provide here this line to initialize the loop variable, and then we need also to increment to go to the next step. That's the only difference compared with the 4 version. The output will be the same to print out this number pattern. Same thing also for matching the 2 objects of lists. Like you can see, in this case, we use while. We have to initialize first those iterator variable incrementation. If you just misplace those 2 lines, it will false everything. So be aware of that indentation and the position of the variables. It's very important. So this one also is the while version of this prime number calculation example. Same thing, we initialize this time the number outside the print statements, and then I also is also initialized like that all the time. For one cycle of the outside loop, we need to reset again I to 2 and then go to all the cases. All the time we have to manage this incrementation, otherwise we'll face issues. As a summary, control statement like if else are very important, and break, continue, pass, they are very important to control the flow of loops. We have seen 2 main loops instruction, for and while, that can be combined with control statements for decision making, and alternative control flow such as break, continue, and pass. We have seen also the structure of nesting loops inside other loops for loops, while loops. So there are very important things that you have to keep in your mind. I've mentioned some of them. The best practice when you deal with loop statements, be consistent with your indentation, okay? To define the block of code that need to be iterated. Keep if else or if else condition clear enough to avoid complex expression that can be difficult to track, because you can have a system that loop infinitely. It may cause problem. Avoid also nesting many loops. Okay, always try to return values using print so you can locate problem if there is some issue in your logic. Use break continue also to control the flow. For example, for while, it's better to use break and continue to control the end of the while also, or change the flow. Pass is used for future, let's say for holding place, for future cases that can be implemented. What I have to cover is the maximum, okay, notion you have to know for building iterative statement in Python. When you access the platform, you have several, well, in your case, you will not see all. So you will see the class you have joined. You say B, right?
Yeah.
Okay, when you enter B, you will see the assignment which is posted. This
So just
assignment.
click the link, and then I can enter the classroom.
Yes, you access Codel platform first, and then you go to classroom, okay?
Okay.
Classroom like this, and then enter. When you enter, you will see week 9 assignments, okay?
Oh, I got it.
Make sure your ID in Codel is your student ID. Otherwise, we'll be facing challenge to map your assignments with the LMS platform. When you access to the Codel platform, you will see week 9 assignments. Open it. When you open, you will see a notebook file like you did for the previous 2 emails. And then you can see the questions. You have 3 sections, okay, like this. You have 5 questions like this. Double click on the question. First question, for example, it will open a new tab. So in the new tab, you have the problem statement of the question, and then you have simple input and outputs. Then your logic should be implemented in this zone. Here, you can execute the logic of your code using execute. You check the results. If the result is correct, you can submit. After submitting, you can close this tab and then go to the next question until you submit all the questions. You can leave the platform. That will be the end of the assignment submission. I hope it's clear for everyone. Inside, when you access your classroom, I will show you.
Okay, thank you.
When you access the platform, you have several, well, in your case, you will not see all. So you will see the class you have joined. You say B, right?
Yeah.
Okay, when you enter B, you will see the assignment which is posted. This
So just click the link, and then I can enter the classroom.
Yes, you access Codel platform first, and then you go to classroom, okay?
Okay.
Classroom like this, and then enter. When you enter, you will see week 9 assignments, okay?
Oh, I got it.
Make sure your ID in Codel is your student ID. Otherwise, we'll be facing challenge to map your assignments with the LMS platform. When you access to the Codel platform, you will see week 9 assignments. Open it. When you open, you will see a notebook file like you did for the previous 2 emails. And then you can see the questions. You have 3 sections, okay, like this. You have 5 questions like this. Double click on the question. First question, for example, it will open a new tab. So in the new tab, you have the problem statement of the question, and then you have simple input and outputs. Then your logic should be implemented in this zone. Here, you can execute the logic of your code using execute. You check the results. If the result is correct, you can submit. After submitting, you can close this tab and then go to the next question until you submit all the questions. You can leave the platform. That will be the end of the assignment submission. I hope it's clear for everyone.